students, welcome you all on YourPedia education. My dear students, this side Mukesh sir, faculty of Data Science and AI department and Computer Science department. So my dear students, today in this video we are going to discuss some basic terminologies which we are going to use in our oral screencast. So my dear students, if you are from any background, you are maybe from EC, electrical, instrumentation, physics, math, stat, civil, mechanical. So, and if you want to pursue your GATE 2024 with the paper Data Science and AI, so this video is related to you only. Fine, my dear students, if you want to appear in the exam Data Science and AI GATE 2024, so YourPedia already launches their dedicated module for CSE separate batch and for non CSE stream students separate batch. The classes are live in nature. So if you want to prepare for the Data Science and AI paper, so you can join YourPedia. If you have any query, contact to YourPedia Education. So my dear students, this lecture is the continuation of the lecture 1. In lecture 1, we just discussed the definition of stat, application of stat in the field of mechanical, civil, physics, math, agriculture, all this stuff. And then we discussed the basic terminologies. Fine, different type of data. We have qualitative and quantitative data. Now, in this video, we are going to discuss the continuation part of the first one. So, we know that we have different category of data, mainly two category of data, and out of that one is categorical data, in which data is divided into some categories. Fine, my dear students. Now, today we are going to discuss about the summarized data for categorical variables. Suppose we have a variable and the type of that variable has some categorical in nature, means the values or the class is category in nature. It means like I have a variable that is soft drink, which is categorical in nature. It means in the soft drink I can use one category as Pepsi, one category as cold drink, one category as Dew, one is Sprite, and all this stuff. Fine, my dear students. So this is a categorical variable. So we are going to discuss some basic terminologies related to categorical variable and what is the use of that, why we are going to use that particular terms. Start with the lecture, my dear students. The first term is frequency distribution. Suppose I have a data set in which that data set contains the values or different data of a categorical variable type. Suppose I have the data set which gives me the information related to the sale in a day of the soft drink. Fine. So I have a shop I want to find out the total sale or the sale of each category. So one category is soft drink. So what is frequency distribution? This is the basic data of a day in which the soft drink like Coca-Cola, Pepsi, Limca, I am just considering the three category in that. In a soft drink category, I am just taking three classes, that is Coca-Cola, Pepsi, and Limca. So what do you mean by frequency distribution? It's a tabular summary. So what do you mean by frequency distribution? It is a tabular summary. Fine, my dear students. We are making a table which gives some information. So which tells about the number of observation in each of non-overlapping classes. It means how many total number of observation, total number of items per class exist. So I have this basic data set of a day, sale of a day of soft drink. So here if I talk about the frequency distribution table, you get to know that the category is soft drink and the frequency. Here if I talk about the Coca-Cola, it's 8. 8 represents 8 customer purchase the Coca-Cola item from my shop in a day. Talk about the Pepsi, it's 12, Limca, it's 5. So total number of sale is regarding the soft drink is 25. 12 plus 8, 20 plus 5 is 25. Now actually only frequency distribution table not give me that much particular idea or understanding of my data set. Fine. That's why we are going to use the frequency distribution table to get more detail about this information, or to get a new terminology, and that is called the relative frequency. So what do you mean by the relative frequency? So it's a, keep in mind my dear students, what is that? Relative frequency of a class. Here category soft drink. In soft drink I have three classes, one is Coca-Cola, one is Pepsi, and one is Limca, which tells about the fraction or proportion of observation belonging to a particular class. So what is the formula to find out the relative frequency of a class? What is the frequency of a particular class in my data set, and how many number of observation in my data set? If we can divide frequency of class divided by the number of observation, I will get to know the relative frequency. See my dear students, I know that the total number of observation is 25, and if I divide 8 by 25, I will get to know the relative frequency of Coca-Cola is 0.32. Now, if I talk about the relative frequency of Pepsi, it tells about 12 divided by 25, which is going to be 0.48, and Limca 5 divided by 25, which is going to be 0.20. It means by seeing now the relative frequency, we get to know that okay, Pepsi is the most likely soft drink, fine. After that the Coca-Cola and the Limca. But still, if I want to represent this data in some graph representation or in some tabular form, then we are going to find out, see my dear students, we are going to find out percentage frequency, which gives me a clear idea. It gives me the value in terms of percentage. So I can say the 50% is purchased by the Pepsi, 50% or to 32% is purchased by the likely by the Coca-Cola and all this stuff. So it means I am going to use the frequency distribution table to get the relative frequency, and if I multiply relative frequency with 100, it gives me the percentage frequency. Now my dear students, what is percentage frequency? Relative frequency, it's no multiply by 100, not divide by 100, it's multiply by 100, keep in mind. It is multiply by 100. See my dear students, now you know that relative frequency is 0.32. If I multiply by 100, that is 32, 48 and 20. So we can know that 48% of sale of soft drink is of Pepsi class, 32% of sale is of class Coca-Cola, and 20% of sale of the class Limca. So that is the use of frequency. So what is that? It tells me about the purchase of a particular class in terms of percentage. Fine my dear students. So we discussed mainly the three type of terms related to categorical data. One is frequency distribution table, next is relative frequency, and next is percentage frequency. Fine my dear students. Moving towards the next topic, that is pie chart. Now if I have the categorical data, and with the categorical data I have different class. With the help of pie chart I can visualize my total sale and just take a better understanding with the help of chart. So I can use pie chart in the case of categorical data concept. Fine my dear students, we have many different type of chart also. According to the demand, according to the applications, we can use different charts to visualize our conclusions or visualize our final result or visualize the analysis of our data set. Fine my dear students. So you know that Pepsi covers the highest area, then Coca-Cola and then Limca. Moving towards the next topic, that is summarizing data for a quantitative, if we have the quantitative variable, we may have the different quantitative type data. So we are going to use how to summarize data for a quantity type variable. See my dear students, we here again we are going to use the concept of frequency. Fine, but my dear students, in the case of categorical data, we by default have we have some classes like class of Pepsi, class of Coca-Cola, class of Limca. But in the case of quantitative variable, we don't have the class, but still we are going to use the concept of frequency distribution. We just take an example here. The given data set tells me the time required to audit in terms of days. So how much time is required to audit something? Fine. Suppose this is the different data set. Fine, my dear students. Now it gives me the quantity, that is 28 days, 33 days, 21 days, 22 days, 17 days, 18 days, 15 days and 15 days. So now the given data set is of type quantitative. Now here the important points comes into the picture, which is very important, is in quantitative data, be careful about defining the overlap classes. Fine, defining the overlap classes, because in categorical data by default we have some type of classes, but in quantitative we don't have the classes. So how we can make the classes? What range or interval we have to consider? How to determine the class limit? What is the limit of that particular class? So these 3 points are very important while considering your data as a quantitative data. So the basic terminology keep in mind, my dear students. So in quantitative data, please be careful about the how you can define your overlap classes. The first point is determine the number of non-overlapping classes. By default, in categorical data set, we have 3 classes: Pepsi, Coca-Cola and Limca. But in the case of days, how you can define your classes, which are overlapping or non-overlapping, because the class should be non-overlapping. If you take the overlapping classes, in that we may face a problem that same data comes in 2 different classes. So we have to always consider the non-overlapping classes. The first point. Second point is determine the width of each class, even because my data set is quantitative, quantity is there. So how much width we are going to consider. And the third point is determine the class limit. We are going to discuss each term one by one. See my dear students, because my data set is quantitative, now I have to determine the number of non-overlapping classes, how much classes I want to make. Suppose in the case of number of days auditing takes, and I have different number of days, or in my data set the values is different, maybe some same, some different. But the point is, now if I take each distinct number as a class, if I take each distinct number as a class, then I have too many classes, and in each class there is very less number of frequency exist, because I am just considering each value as each different or distinct value as a unique class. So in the case of quantitative data set, we are going to use histogram to visualization purpose. See my dear students, suppose I have data set having these many distinct classes, like 10 days required, 12 days, 13 days, 15 days, 17 days, 18 days, 20 days, 21 days, 24 days, 25 days, 26 days, 27 days, 28 days. Suppose I am just considering only 2 values, one is this one and one is this one. Fine, then if the number of values are too low, then how I can make the histogram, and there is no good like observation with the help of histograms. And suppose as the number of values increases, so now it gives me somewhat a better picture of my variability. But suppose now I am again more number of values I am going to use, I am just taking more number of observation in my data set or in my population or in my sample, then it gives me a better understanding of my data set. Fine, my dear students. So in this way, my dear students, it is you need to be very careful while determining the non-overlapping classes. Fine, my dear students. So, but in categorical data type, by default we have the classes, but in the case of quantitative data type, we don't have the classes. So we have to determine, we have to fix our number of classes. The second point is how to fix this up, depends upon the data set. Fine, my dear students. Now the second point is how to determine, or what is the importance to determine the width of each class. Suppose we just decide that okay, I have 50 like 50 number of observation in my sample or in my population. Fine, my dear students. Now if I consider only two classes, then there is a chance that the width of one class and the width of next class is somewhat different. Fine. So it means if I just consider two class, that is class 1 and class 2, and it tells about the frequency. Suppose this tells about the 25 and this point tells about 20. So again I have to determine in a very careful manner that how I am going to decide the width of my class. Fine, my dear students. So my dear students, if I just consider one class, then all the data comes in one class, and the width of that particular class is too high. But if I take two classes, then width of my class is going to be reduced. And if I decided to make my width of each class, or I just considered each value as a different class, then while constructing the histogram, each value, the width is too small, then again I am unable to check the variations in my data set. So the point is, you need to determine the width of the class. Again, total number of class, how many class you want, and what is the width of each class. That two factors are very important in the case of quantitative class. Fine, my dear students. Now see my dear students, here width be the same of each class. So general guidelines while considering the width of each class is, you have to keep the width of the each class should be almost same. So choice of the number of classes and the width of classes are independent decision, are not the independent decision. Why? See, the very important point, very important point, you may get this question in your GATE in terms of finding the correct statement. Keep in mind, my dear students, the number of classes and the width of class are not independent. Why, my dear students? If you take more number of classes, your width of each class is so small. Vice versa, if you take less number of the classes, then width of each class is too high, because more number of observation, more number of data present of a particular class. Fine, my dear students. That's why if the large number of classes means small class width, the width of the class, if I just see, this is frequency, this is the class. So if I take each unique number as a different class, then my histogram is like fine. It means the width of each class is so small. But if I take less number of classes, then my width is somewhat large. So we have to determine very carefully in the case of quantitative variable data type, what we are going to decide, how much classes we are going to decide, and what is the width of my class. Fine, my dear students. Next, third, how to decide the width of each class. See, my dear students, if you want to find out the width of your class, then you just take some two values from your sample or from your population, that is the largest data value and the smallest data value, and do the subtraction between that. Fine, my dear students, and then divide by the number of classes. Suppose I want to make 5 classes, then in the previous my data set, in auditing data set, the largest value is 33 days, smallest value is 12 days. So approximate width class is 33 minus 12 divided by number of classes, that is 5, is going to be 4.5. It means if you can round up, you will get 5. It means the width of my class is 5 and total number of classes I just take is 5. Now how you are going to start? Even though your smallest data value is 12, what I can do is I just take a class from 10 to 12, whatever the entries or the total number of entries including 10 days to 14 days, the frequency is 4. It means the number of days from 10 to 14, 4 audit requires to auditing 10 to 14 days. Now 8, in the previous case, if I go to a data set, 8 entries are there which exist is between 15 to 19, and 15 and 19 are inclusive in nature. Fine. It means 8 auditing takes the days between 15 to 19, and 15 to 19 are included in my case. Fine. In the same way, I just find out the frequency, and here I just take the interval or the range. Fine, my dear students, or the class, and the width is my 5. Each class width is in my here 5. Fine, my dear students. So it means the frequency distribution tables tells me that the most frequent occurring auditing time is 15 to 19 days. Why? Because this is the highest value. This is the 4, 8, 5, 2 and 1 days required. So 8 is the highest value which requires 15 to 19 days. Fine, my dear students. It means it tells most frequent occurring auditing time is 15 to 19 days, and it also tells me only one audit required 30 or more days. Only one audit required 30 or more days. So in this way we are going to decide the classes, the width of each class. Fine, my dear students. Then we have one last point is class limit. So must be chosen so that each data item belong to one and only one class. We have to limit the class. It means each value belongs to our data set must belong to only one class. We cannot consider one class is of 10 to 14 days and next class is of 12 to 16 days, because there is a chance that one data having the value 13 that also exists in the range or in the class interval of 10 to 14 and 12 to 16. It means that's the point of class limit that says that each data item must belong to one and only one class. Fine, my dear students. So, with the help of frequency distribution, we are going to get, or we are going to conclude something from our data set. Next is class midpoint. Sometimes what happen, whenever we are just making our class, there is a requirement of finding the midpoint of that class. Like my first class is 10 to 14, next class is 15 to 19, then what is the midpoint? What is the midpoint? Fine, my dear students. How you can find out? Just take the lower values of two class, that is 15 minus 10, 5. 5 divided by 2, 2.5. You can add 2.5 to each and every lower value. 10 plus 2.5, 13 or 12, whatever you want. So I just take the lower value, 12. 17, 19, 27 and 32 are the midpoints of my previous classes. Fine, my dear students. And the next is relative frequency and percentage frequencies. In the same way, in the categorical data type or data set, we are finding the frequency distribution, relative frequency and percentage frequency. In the same manner, here we have to find out, or we have to determine our class, then width of the class, and then already we get to know how to write the frequency, and with the help of frequency the total frequency is 20. So 4 divided by 20, again the same, in the same case 20, 0.20, 0.40, 0.50, 0.10, 0.05, and the total relative frequency should be 1. Again this type of question you may face, that the total frequency is 1, relative frequency is 1, percentage frequency is 1. So accordingly you have to find out what is your percentage frequency in terms of 100, relative frequency in terms of 1, and frequency is total number of observations. Fine, and if you multiply 100 to the relative frequency, you will get percentage frequency. So by seeing this percentage frequency column, I get to know that most of the auditing takes 15 to 19 days, or 40% of data requires 15 to 19 days of auditing. Fine, my dear students. Again I can say, with the help of histogram, we are going to find out the variations, the shape of my data, the variations of my data, which is very important. Now I am going to discuss one more term, that is cumulative distribution. We know relative distribution, frequency distribution, relative distribution, and next is percentage distribution. Then what is the use of cumulative distribution? Sometimes what happen, our query is like total number of auditing which take less than 25 days. So in that case, either we can use our previous table and one by one we have to add the things, or just make a cumulative frequency table. See, my dear students, auditing which are take less than or equal to 14 days are 4. Their cumulative relative frequency is 4 divided by 20 is 0.20, and their percentage is, if I multiply by 100 to the cumulative relative frequency, 0.20 into 100 is 20%. So that the number of auditing requires less than equal to 19 days. We know that 4 plus 8 is 12. Here, my dear students, 14 is also included. Here keep in mind that the auditing which takes less than equal to 14, that is 4 is also included here. It means the number of auditing which takes 15 to 19 is 12 minus 4, which is going to be 8. So 8 plus 4 is 12. That is the meaning of cumulative. Next, The number of auditing which take less than equal to 24 days is total 17. Number of auditing which takes less than equal to 29 days is 19, and number of auditing which take less than equal to 34 is total. Fine, my dear students, and with the help of percentage frequency we get to know that 95% auditing just take less than equal to 29 days. So with the help of cumulative frequency distribution table or cumulative percent frequency table, we get to know the total or overall how the queries, like if I want to find out total number of auditing which take less than equal to 29 days. It means only 5% auditing which takes greater than 29 days. Fine, my dear students. So in this way cumulative distribution is again a very important topic. So my dear students, today we just discussed some of the key terms, and if you have any query you can send in the YourPedia comment section box video or talk to me by reach out to YourPedia team. So my dear students, today we discuss frequency table, frequency distribution table, relative frequency table, percentage frequency table, and then cumulative frequency table. Fine, my dear students, this is the lecture 2nd of stats. In the next videos will be again the continuation part of this video. So please keep watching, and if you want to again prepare for the data science and AI, you can join YourPedia dedicated module for CSE branch separate batch and for non CSE stream students having this separate batch. The live classes are going on, so if you have any query please reach out to YourPedia Education. Thank you so much.